Hi everyone, it's Math with AUB. Today I have selected some questions from Inter touching overall course of second year within no time. Touching, revising overall course of Inter within no almost course of Inter. Let me call it a classical frame. Question number one based on limit x tends to 0. Limit x approaches to 0 tends to 0 3 times e raised x minus e raised minus x minus 2 overall x. What is our flexibility? How to handle limit question or how to find domain of a function, whether it is defined or undefined, continuous or discontinuous. Put direct limit. If denominator is not equal to 0, then it's our answer. If denominator does not equal to 0, then it's our answer. If we put x is equal to 0, our denominator is 0. Traditionally, at our second year level, we utilize this formula. Limit x tends to 0, e raised x minus 1 overall x, it's equal to 1. We utilize this formula. Limit x tends to 0, 3 e raised x minus 1. I have compensated 1 for this one as well as 1 for this. E raised minus x minus 2 plus 1 minus 2 plus 1 overall x. Now the game starts. I have subtracted as well as it added 1. I have subtracted as well as it added 1. Limit x tends to 0. 3 e raised x minus e raised minus x, that's plus 1. Or let me arrange in a different fashion. Let me write in that fashion. Yes, limit x tends to 0. 3 e raised x minus 2 minus e raised minus x. Now add and subtract 1 in the next step. What is the deficiency of 1? Add and subtract 1. Where lies the mystery? Let's see and find out. Limit x tends to 3 e raised x minus 2 minus 1 minus e raised minus x plus 1 overall x. Here lies the mystery. I have subtracted as well as added 1. Why I have written 2 with 1? Minus 2 minus 1, minus 2 minus 1, it will become minus 3. Minus 2 minus 1, it will become minus 3. Minus 3, 3, take 3, cancelled out, and your question is going to take shape. Limit x tends to 0. 3 e raised x minus 3 minus e raised minus x plus 1 overall x. Taking 3 common, then dividing x separate, and we are arrived at the result. Limit x tends to 0. 3 common, e raised x, nothing remains, 1 divided by x. Taking minus common, it will become e raised minus x minus 1 overall x. It is fit formula of 1, limit x tends to 0, it's equal to 1. For this, there is negative x, there must be minus, there is deficiency of minus, compensate it by dividing and multiplying. It's equal to 1, 3 times 1 minus e raised minus x minus 1 divide as well as multiply. Now again it is formula identity, it's equal to minus 1, 3 times 1 minus, it's also equal to 1, 1 times minus 1, 3 minus plus 1. So 4 is our answer. Or one can utilize Hopital rule. However, Hopital rule is not applicable at inter level or second year, but we can in order to solve MCQs. 3 e raised x minus e minus x minus 2 overall x. Differentiate numerator separate, denominator separate. Don't apply quotient formula, separate. Numerator and denominator differentiate. Limit x tends to 0. It will become 3 e raised x into 1. Negative e raised x. Derivative of power is minus 1. Derivative of 2 is 0. Derivative of x is 1. 3 e raised x minus plus e raised minus x. What's our limit? 3 e raised 0 plus e raised minus 0. Any non-zero quantity having 0 power is equal to 1. Any non-zero quantity having power 1 is equal to 1. That's our answer. So you can directly apply a hack to arrive at a result for MCQs, or that is the more orthodox or subjective method to make this formula. To make this formula, where lies the mystery? If we add and subtract 1 in that, it will become minus 3 plus 1. Take 3 common and you are going to get through, and you are going to get through. That is the tip in that case. Add and subtract 1. Minus 2 minus 1, it will become minus 3. Take 3 common, it is e power x minus 1 and shift 1 here, minus e raised x plus 1. If you take minus common, again you are going to have same identity this. Okay, moving towards second question. Second question says, in what ratio does the point C24 divides the join of A and B, where the coordinates of A are 7, 9 and coordinates of B are minus 1, 1. Minus 1, 1. Question number 2. Tedious sauce in teaching, raise the whiteboard. In what ratio does the point C4, let me draw a rough sketch. There is a point C having coordinates 2, 4, write A here, 7, 9 and B is minus 1, 1. That's our B. Even you can shift this one, it is not drawn according to scale. Dividing point, a point that is the center that divides, it must lie B and must lie at the center. It's our xy according to formula. This is our x1, y1, this is our x2. But it's okay if you write this one as x1, y1, this one x2, y2, because length remains same, whether to count from A to B or from B to A. But no compromise on xy. Ratio formula, apply ratio formula on any coordinate. Either abscissa, take x, you are going to get same ratio, or take coordinate y, you are going to have same ratio. Suppose the ratio is k1 ratio k2, question mark. Applying abscissa, x is equal to k1 x2 plus k2 x1 overall, k1 plus k2. What is our x2? k1, question mark, to be found out. What is our x2? That's minus 1 plus k2 to be found out. What is the value of x1? 7 over k1 plus k2. Now manage the ratio of k1 over k2. Shift k1 plus k2 here, 2 times k1 plus k2. It will become minus k1 plus 7 k2. Okay, 2k1, 2k2 minus k1 plus 7k2. Shift k1 one side, k2 on the other side. 2k1 plus k1, 7k2 minus 2k2. How much? 3k1 is equal to 5k2. We are interested in the ratio k1 k2. K1 ratio k2 means k1 over k2. K1 over k2. So shift k2 here. It will become 3 times k1 over k2 is equal to 5. Manage 3 there. So our ratio is k1 over k2, 5 ratio 3. 5 ratio 3. So our required ratio is 5 ratio 3. 5 ratio 3 is our answer. I have taken abscissa. Even you can take ordinate. You are going to get same answer. Let's see and find out. Now taking ordinate, why? It also works and we arrive at the same result. This is mathematics. Take the traditional path. Your concept must be clear. Apply formula. You are arrived at the result. No doubt. Now taking y, the central point, see, it's 2, 4. Or A is 7, 9. B is minus 1, 1. Now taking y, ordinates, y is equal to k1, y2 plus k2, y1 over k1 plus k2. And this is our xy. No compromise on the central point. This is our x1, y1, this is our x2, y2. This is x2, y2, this is our x2. No compromise on the dividing point. Y is 4. K1, we are interested to find. What's y2? 1. K2, we are interested to find y1, 9 over k1 plus k2. Manage k1 plus k2 on the left hand side. It will become 4 times k1 plus 4 times k2 is equal to k1 plus 9 times k2. K2 on the left hand side, K2, K1 on the left hand side, K2 on the right, separate them, 4K1 minus K1, 9K2 minus 4K2, what we have? 3K1 is equal to 5K2, 5K2. We are interested in the ratio K1 ratio K2. K1 ratio K2 means K1 over K2. Shift K2 here, it will become 3K1 overall K2. For manage the ratio of K1 K2, 3 will be in division on the right hand side. K1 K2 over K2 is 5 ratio 3. Look at this. We arrive at the same result. K1 K2 ratio is 5 ratio 3. 5 ratio 3. Okay. Moving towards next question. At second year level, especially in entrance test, function derivative works wonder for you. Function derivative. Always hunt for function derivative. If it is a differential equation or area under the curve question, it might be simple one. For only integrate function derivative works wonder for you. Let's see how. Sine or inclination is ln x over x 3 minus cos ln x raised 1 over 2 dx. Don't you worry. 1 upon 2, that might be our function. That might be our function because it has some power. What is differentiation of cos? Take that cos ln x. Integration of cos is sine. That's our inclination, right? Same. Then derivative of the angle ln x means 1 upon x. Look at this. Sine ln x and x both are present. Sine ln x and 1 upon x both are present. So it is our function. It's our derivative. Function derivative, function derivative, function derivative. It works wonder for us. Okay. Now if I suppose f is equal to 3 minus cos ln x. In case of supposition, don't take overall power. Don't take overall power. F dash, differentiation of 3 is 0 minus differentiation of cos is negative sine, angle same. Differentiation of cos minus sine, angle same. Then differentiation of angle 1 over x. It will become minus minus plus sine ln x into 1 over x. So let me write this data in a proper fashion. Shift the function in the numerator because function does not have power 1. If function having power 1, then it is a case of ln. If function in the denominator having power 1, it is case of ln. If not, then move it into numerator and work traditionally. Minus 1 over 2. We have sine ln x over x dx. Now this is our function f power minus 1 upon 2. This is our derivative f dash dx. Function derivative, function derivative. Add 1 into the power of function. Minus 1 upon 2 plus 1. Minus 1 upon 2 plus 1. It will become minus 1 plus 2. Positive 1 upon 2. Divide with the same. Plus c. Double upon 2 times what is our function? 1 upon 2 means under what is our function? 3 minus cos ln x plus c. That's our answer. That's our answer. If differentiation of minus cos is positive sine ln x, differentiation of ln x is 1 upon x. It is present here. Present function derivative. Function derivative. If power of function is not 1, if power of function is not 1, write in numerator and add 1 simply. If power function is in the denominator having power 1, then it's case of ln. Then it's case of ln. So in that case, we have 1 upon, what is our option? 1 over 2. Nobody has written the complete correct option. 1 upon 2. That we manage this. Okay, cool. Moving towards next question. It is based on differential equation. At your second year level, all questions are separable differential equation. Only one technique of differential equation is present, that is separable. After separable, homogeneous. Homogeneous has two cases: homogeneous reducible to homogeneous, then exact, Bernoulli, linear, and higher order differential equations. In our second year, we have only one, that is separable differential equation. Let's see how. This one, dw over dz is equal to root w times z 2 times w minus 3z plus 6. We don't need the differential dw in numerator or dz. dw in the numerator, dz must be in the numerator. Shift here. It will become dw same dz. If I write these two, if I take w common from here, it will become z minus 2 minus 3 common. What it is? Z minus 2. Okay. dw is equal to 1 bracket is z minus 2 and other is w minus 3 dz. They are in multiplication. We distribute this root. It can be written as z minus 2 times root w minus 3 dz. With dz, z suits. With dw, w suit. Shift w here mathematically. dw from multiplication to division. W minus 3, it will become root z minus 2 dz. Okay. Power is 1 upon 2. Differentiation of w is 1. W minus 3 minus 1 over 2 dw. And here z minus 2 raised 1 over 2 dz. We have to integrate with respect to w with respect to z. With respect to w with respect to z. It has power over 1 upon 2 and differentiation of w is 1 because with respect to w it has derivative 1. With respect to z it has derivative 1. That is always present. Function derivative, function derivative, function derivative. Add 1 in the power of function only. It will become w minus 3 by adding 1 it will become positive 1 upon 2. Positive 1 upon 2 is equal to z minus 2 adding 1 it will become 3 upon 2 divided with the same plus c or it will become 2 w minus 3 2 over 3 it will become z minus 2 3 over 2 plus c. That's our answer. Mostly integration is based on function derivative. Function derivative, that is the most typical question that is present at second year level in differential equation. Separable differential equation only present in your second year. And I have done a good question for you. Okay. Another humongous question. Combined equation of pair of straight line passing through a origin. That is ax square plus 2hxy plus by square is equal to 0. And we have given a condition. Gradient of one line is twice of the other. Gradient of one line is twice of the other. Then prove the condition at h square is equal to 9 times ab. 8h square is equal to 9 times ab. Combined equation of straight line passing through origin, that is ax square plus 2hxy plus by square. Second degree homogeneous equation. Second degree homogeneous equation or combined equation of pair of straight line passing through origin. Solve this one, split this one according to y, quadratic in y. Let me write by square plus 2 times hxy plus ax square is equal to quadratic in y, quadratic in y. So value of a is b, value of b is 2 times hx, quadratic according to y, y is our variable, and c is equal to ax square. So y is equal to minus b means 2hx plus minus b square means 2hx square, 4 times a means b, c means ax square. Overall 2a, value of a is b in that case. Now simply solve. Y is equal to minus 2hx plus minus root 4h square x square minus 4ab x square over 2b. Taking 4x square common, 4x square common, we have minus 2hx plus minus 4x square common. What we have? H square minus ab overall ab. 4x square is a perfect square quantity. 4x square is a perfect square quantity. Its root is 2x. So y is equal to minus 2hx plus minus 2x times root h square minus ab overall 2b. That's our 2b. Overall 2. I have a space. Let me manage here. Taking 2x common, y is equal to 2x only common. What remains? Minus h plus minus H square minus AB overall 2B. B cancel. Look at this. Y is equal to X times minus H plus minus H square minus AB overall B. Now we can easily compare this one with slope intercept form. Y is equal to mx plus v. Coefficient of y is 1. Quadratic in y gives us direct slopes. So slope of one line is minus h plus h square minus AB overall B, and the slope of other line is minus h minus h square minus AB overall B. Erasing this, now gradient of one line is twice of other. You can write m1 is equal to m2 or m2 is equal to m1. Gradient of one line is twice of other. You can even utilize the direct gradients of this one. This is m1, this is m2. Utilize here. M1 is minus h plus h square minus AB overall B. 2 times minus h minus h square minus AB overall B. B cancel out. It is in division. On the right hand side multiplication. It is in division. On the left hand side it is in multiplication. Cancel out. Multiply minus 2 throughout. Minus h plus h square minus AB minus 2h minus 2 times root h square minus AB. Shift h on the one side, the root quantities on the other side, minus h plus 2h minus 2 times h square AB minus h square minus AB. Okay, minus h plus 2h, the result is positive. Minus 2, it is minus 1. Minus 2 minus 1, minus 3 times h square minus AB. Squaring both sides, we have h square of 3, 9, getting rid of square root, h square minus AB. Multiply 9 throughout, h square is equal to 9 times h square minus 9 times AB, or h square minus 9h square is equal to minus 9 times AB. Positive h square minus 9h square, it will become minus 8h square is equal to minus 9 times AB. Minus cancel. So we arrive at the result that we have to prove. 8h square is equal to 9AB. 8h square is equal to 9AB when gradient of one line is twice of the other. One can manage the gradient of this line direct by keeping in mind slope of one line is minus h plus h square minus AB overall B, while the slope of other line is m2 minus h minus h square minus AB overall B. Angle between two lines for this is given by the formula tan theta. For this specific equation, tan theta is equal to 2 times h square minus AB overall A plus B. Sometimes it is asked that what is the condition when the given lines are parallel? Given lines are parallel. Parallel means h square minus AB is equal to 0. H square minus AB is equal to 0 for parallel lines. For perpendicular, denominator is 0. A plus B is equal to 0. For perpendicular lines. One can ask from where these conditions prop up. From where these conditions comes. Let's see and find out. Let me give you a good idea about that as well. We are familiar. Angle between two lines from traditional. What is our traditional concept? For parallel lines, M1 is equal to M2. Parallel lines. For perpendicular, product of M1 into M2 is equal to minus 1, or slope of one line is negative reciprocal of other. Normally, angle between two lines is given by tan theta plus minus M2 minus M1 overall 1 plus M1 into M2. Tan theta. Parallel lines means angle 0 or 180. 0 or 180. For this, tan theta is 0. So M2 minus M1 is equal to 0. For parallel lines, when angle is 0, tan theta is 0. When angle is tan 180, it is 0. So M2 is equal to M1. M2 is equal to M1. For perpendicular lines, the denominator is 0. 1 plus M1 into M2 is equal to 0. Or M1 into M2 is equal to minus 1. Or one can utilize the condition m1 is equal to minus 1 over m2. Look, when lines are parallel, angle is 0, sine 0, one can manage.